So one project we've been working on with a lot of success recently is trying to understand butanol. So there's a proposal to switch over or supplement ethanol as the main biofuel in this country with butanol. Butanol has a lot of advantages. It has higher energy density. It's more similar to gasoline, so it avoids a lot of problems of mixing up gasoline and ethanol. It has lower vapor pressure, so it makes less smog. And so there's a lot of interest in doing that. And there are microorganisms that would make butanol instead of making ethanol. Butanol is the version of ethanol with 4 carbons instead of 2. But there's 4 isomers of butanol, and they don't know which of those isomers would be the one to make. And in fact, there's 2 companies that are trying to commercialize it, and one's making one isomer and one's trying to make the other one. But we looked into this and we found out that, to our surprise, that those 2 isomers have very, very different ignition properties. So their octane numbers are more than 10 units different. And so that's a very big impact on how they would perform in an engine. And it really constrains how you could use it because you have to have an engine that's matched to the octane number of the fuel that you're going to use. So then we looked in that, tried to figure out chemically why is that? Why are the octane numbers so different? And are there new alternative engines that you could use that might burn butanol even more efficiently? And if that was possible, then that might make it possible to have butanol be more valuable than just regular gasoline. And that would help with the commercialization a lot. So the problem with all the biofuels is that it's a lot cheaper to dig oil out of the ground in Saudi Arabia than it is to actually grow some biomass and then convince some microorganism to convert it into the fuel you want, separate it out, purify it. And because of that, the fossil fuels always have an economic advantage. So if you can find some performance advantage of the biofuel, then that might give you a chance to succeed in the marketplace without a really big subsidy. So we've been trying to find those opportunities. One really interesting angle there is there's a new kind of engine called homogeneous charge compression ignition, and different variants on that use what's called low temperature combustion, where there's no flame, but the fuel reacts anyway with the air. And those engines make much less emissions than conventional engines, and if you run them properly, you can get much higher efficiency as well. But they're tricky because they depend a lot on the reactivity of the fuel. And so they're not as robust over all the ranges of fuels as conventional engines like gasoline or especially diesel engines. But getting lower emissions and higher efficiency is worth a lot. So we've been working hard to try to figure out how to find fuels that would actually work in those engines and how you could possibly make them economically. And the alternative fuels work in the butanols, that's been funded through the Department of Energy as part of a huge center called the Combustion Energy Frontier Research Center. And that's a multi-university center involving many of the leading combustion researchers in our country. And we decided to work together on butanol because it was becoming commercial and it was a fuel that we could study experimentally and theoretically. It was in this scale of things that we could handle well as a first trial case. And so that's worked out very well. We published several papers and really feel like we really understand what's happening with that now. And that project also runs a summer school for teaching combustion science to new graduate students. So actually just last week, 2 weeks ago, my students were all down at Princeton and I went down and gave some of the lectures at the summer school. And they're learning all about mechanical engineering and chemical engineering and chemistry, all the different components of combustion and practical things like I was teaching about the alternative fuels class there. That was very, very interesting.